Computer Primer. In this lesson, we're going to talk a little bit about some of the basics of computers. The Intro to Music Technology course is certainly not a computer course, but I want to make sure that we have some common language to talk about the key concerns when we're designing computer systems to work with digital audio and digital video. So let's start by taking a quick trip through the history of computers and music. During the 1950s and 60s, computers were generally very expensive, and access was limited mostly to researchers at universities and other major R&D facilities. We don't see any computer music from this era, though there were interesting early documents written by computer scientists exploring the idea of working with audio in computers and other things that became very important a generation later. This included early use of computers to generate melodies and other musical content, as well as early research and early examples of the use of computers to generate sound. The earliest we really talk about digital technology making its way into recording studios and into music production would be during the 1970s. During the 1970s, digital technology began to make its way into recording studios as people explored the use of computer technology in digital instruments, digital recording, digital signal processing, digital audio playback, and other technologies that eventually became a part of the backbone of modern digital audio. It's during the 1980s that we see digital technology really come to the forefront of modern music. During that era, digital technology becomes much more affordable and much more common. Home computers with audio and MIDI capability began to redefine the concept of the home studio, and, importantly, early notation software was developed. By the 1990s, home computers with audio and MIDI capability began to redefine the concept of the home studio. The earliest professional-grade personal computers capable of high-quality audio recording made their way to the market. And eventually, by the end of the 90s, they had dropped in price dramatically. Digital signal processing continues to advance during this era, with more and more digital signal processors becoming available with increased processing power, increased memory, increased user flexibility, and new algorithms that took advantage of that advancing processing and memory. We also see notation software advance to the point where it begins to compete with traditional typeset printed music, and by the end of the 1990s, traditional typeset music had basically disappeared. And for the last 20 years, we've really seen digital publishing as the norm for music publishing. By the 2000s, we enter the era of the laptop. By this point, laptops had become quite affordable, and the technology had advanced to the point where they were capable of handling advanced audio operations. We began to see portable recording setups, musical instrument performance systems, portable music creation systems, all built around laptop technology. Digital audio continues to advance as more and more powerful computers are capable of running more advanced programs and algorithms. By the 2010s, we began to see the era of what I consider blended technology. We're surrounded by various types of computers, and they are embedded in devices like smartphones, tablets, laptops, workstations. All of these devices are now more than powerful enough to perform traditional music functions for us. And we begin to see the use of new technologies that blend the use of these devices. So, for example, the idea of controlling laptop instruments with a tablet or a phone, or controlling the DAW from a portable device over a network. It's also during this era that we begin to see a major change in the way we consume media as streaming becomes the norm. Looking forward to the next decade, some of the questions that are being raised: how will virtual reality and augmented reality become better and more common in our day-to-day life? How will consumers listen to music? How will content creators continue to create more engaging and immersive media? And finally, a question very important to us in this program: how will musicians continue to earn income from their creations? Of course, I don't have any answers to these questions, but these are important things that we should be considering as we look forward to the next step in all of our music careers. I want to cover some basic concepts here. In the broadest sense, computers are systems that carry out sequences of mathematical and logical operations. Specifications are generally based on the speed at which some operation can be carried out or on the amount of data to be stored or transferred during a particular period of time. At the core of modern computing are processors. Processors include the CPU, which is the central processing unit, graphics processing units or GPUs, and any other supporting processors that help the CPU carry out its primary tasks and functions. Processing power will impact every aspect of computing performance. So for us in music, it'll impact everything from the number and the size of virtual instruments that you can stably run on your system to the number of tracks and plugins available for processing. For video and graphics, it'll impact the rate that video can be rendered, as well as the quality of the video that can be played without problems. In other words, if we want to be able to handle high-quality video like 4K video in real time, we're going to need a very, very powerful processor. The more you plan on having your computer do, the greater processing power you will need. However, as we'll talk about later, we don't want to overspend on processors. We want to buy just enough to carry out the tasks that we need and no more. Processors are rated based on the rate at which operations and instructions or programs can be carried out, which is reflected in the clock speed. This is indicated in the unit hertz, commonly modified by an SI prefix. Currently, modern processors are generally operating in the realm of gigahertz, or the 1 billion hertz range. That is, their clock is working at a rate of 1 billionth of a second. For some tasks, efficiency can be increased by having multiple processors, or what's called multiprocessing. This technology became common in the late 90s and early 2000s, and for the last 2 decades, they've often been built into a single chip, which are called multi-core processors. Data storage. Data storage can be divided into 2 broad categories. Primary storage, which is storage directly accessible to the CPU. We commonly call this memory in personal computing. And secondary storage, storage that's only accessible through input-output channels. This would include hard disk drives and any other storage technology on the I/O bus. Random access memory, or RAM, is where data for the processors is temporarily stored. It is directly accessible to the CPU. RAM can have a big impact on various music and video operations. Most music software will have minimum RAM requirements, so make sure that you check the requirements when outfitting a system. Memory is a type of data storage called volatile storage, meaning that memory will only store data when the system is powered on. Once the system has been powered off, that data will be lost. Now, because the data in memory is volatile, computers need some type of non-volatile storage solution which can provide data that the computer needs when it starts up, as well as any long-term storage needs for data. Commonly, this is implemented through a hard disk drive, commonly called an HDD or just an HD. This includes traditional spinning drives as well as modern solid-state drives. Data storage requirements for music can become quite large for a big project. Storage for video projects are typically even larger. So when outfitting a system, we need to think about system usage to ensure that we have sufficient storage for all of our needs. Input and output devices, or I/O. Input and output on computers takes many forms, including data I/O and interfaces for human use. Some common data I/O devices include data storage devices like hard disk drives, external interface systems like USB, FireWire, Thunderbolt, etc., network cards like Ethernet or Wi-Fi, audio cards or devices, and video cards and devices. Common human user interface devices, which are part of the category of input and output devices, are visual monitors, printers, and audio output to internal or external speakers. Some common input devices include keyboard, mouse, touchscreen, but to this on the music side, we could add MIDI instruments, including MIDI keyboards, MIDI guitars, MIDI drums, We could also add various devices created specifically for interfacing with data for particular pieces of music. This is common in the world of contemporary music, where composers will often design interfaces so that end users can have an interactive experience with their musical creation. We commonly call these installations. Finally, we have external devices. External I/O devices are connected via system interfaces. Commonly, the ones we see in audio are USB. We're currently up to USB 3.x, but we commonly see USB 2 and even USB 1 devices in the audio world. USB 4 has been announced and will be forthcoming in the next few years, so we'll be looking forward to some new interface options and increased interface speeds there. Thunderbolt, currently in Thunderbolt 3, is actually part of the new USB 4.x interface. So Thunderbolt was an Intel-designed technology that was introduced to market about 10 years ago and has been very common for audio interfaces. We went through Thunderbolt 1 and 2, and we still see those audio interfaces around that use Thunderbolt 1 and 2, but we are looking at some new interface technology that will basically bridge the gap between Thunderbolt and USB. Finally, we see some legacy devices that are often FireWire in our world. A lot of older audio interfaces still commonly use the FireWire interface, even though this has basically been deprecated by most of the technology companies making computers. In other words, when you buy a new computer, it will not have FireWire built into it. To use a FireWire device, you would generally need to access FireWire through a USB to FireWire converter or a Thunderbolt to FireWire converter. Finally, we have Lightning, which is used on iOS devices like iPhones and iPads. As people have started using these for music creation and music performance, we've seen a number of companies introduce external devices that can plug straight into your iPhone or iPad for audio, MIDI, or other interface protocols. So, some common tips on setting up a computer system for working with audio and video. One of the most important tips that we generally try and implement consistently across our computers here on campus. We try and separate the system drive from our data drive. In other words, the drive where our operating system is being stored is a separate drive from the place that we're going to store our audio and video data. Now, there's a couple of reasons that we do this, including security, but one of the most important reasons that we do this is to increase the performance of the system. By having multiple drives handling data, we're able to increase the data throughput that we're actually able to achieve at any given time. Trying to record audio onto the system drive typically results in a decreased track count and possibly some data errors that may come up. In other words, we may see performance errors that emerge. Another important tip when building or designing a system is to consider the principle called the bare maximum. Now, this is a clever turn of the phrase that I first heard from architect John Storick. It's a paraphrase of the idea of the bare minimum. In other words, we want to design a system to perform as we need it to perform all functions and all tasks that we need, but we just barely want to exceed that. Anything beyond that, we're spending money to outfit a computer to do things that we won't take advantage of. In other words, we've wasted money. So, one of the things that you'll find, especially as a student, is that a computer is not a safe investment. I would never recommend that a student go out and spend a lot of money to buy a very expensive and fancy computer. First, you'll never recoup on it. By the time you're out working in the professional world in 4 years, 3 years, 2 years, that technology will likely already be obsolete. The other thing is that you likely won't need that high level of performance for the kind of work you're going to be doing over the next few years. So you've spent a lot of money to buy performance that won't actually benefit you in your day-to-day work. So I would generally recommend to not overspend on a computer. There are some areas where it makes sense for a student to invest some money. This would be technology that has a much longer service life. For example, studio monitors, speakers, are a good place to spend money because the life expectancy on a good pair of speakers could be 10, 15, 20 years. You're likely to see a good return on investment there. Microphones are generally good investments. In 10, 15, 20 years, a good microphone that's been taken care of will still be a good microphone. A great computer from now in 20 years is likely to be a doorstop. Finally, as we're thinking about how to reach this level of bare maximum, we want to think about usage-based design. In all likelihood, on a budget, you're not going to be able to build a computer that will be able to perform all tasks that might ever happen. You need to think about the specific tasks you're going to be doing. And an example where this comes up would be thinking about buying an audio interface. If you're only ever going to be recording 2 to 3 microphones at any one time, buying an interface with 16 microphone preamps and 16 inputs and outputs doesn't really make a lot of sense. You're going to end up spending a lot of money for features that you won't use. On the other hand, if you're going to be tracking drums, you may very well need at least 8 channels of input. So give some thought to what you will actually be doing with your system. For a lot of home recording applications, recording drums isn't realistic anyways, so why build a system that would be capable of doing this thing you're never going to do? It makes more sense to simply buy what you need. So one of the things that I recommend is to spend some time, at least a few days, mapping out everything that you think you'll be doing over the next year or two with your computer system. As you do that, it should clear up where it makes sense to spend money and where it doesn't. Finally, avoid fads and fancy marketing hype. The companies that manufacture gear are in the business of selling us gear, and as such, they're in the business of convincing us that we have a need for their product. Quite often, this really isn't true, and one of the problems that can happen for students is when we buy the latest, fanciest thing, it may not be compatible with other systems. It's often better to buy the tried and true, simply to know that you're going to have a reliable working system during the period that you need it, rather than buying something that might not actually be around 6 months from now or a year from now, or that won't interface with anyone else's system. Lastly, let's touch on a few details about UMass Lowell computers. We do not allow any food or drink around computers or audio equipment. I cannot stress this enough. First, it's important for you to understand that it is simply the rule. If you are caught in violation of this rule, you may lose access to computer labs. That will impact your ability to pass classes. Being in a class doesn't entitle you to break the rules and continue to have access to studios or computer labs. You have to follow the rules. More importantly, this is a habit that we want to instill in you because it's one that makes sense. The first time I had experience with this, I once spilled a cup of coffee on one of my computer keyboards. It was really frustrating because I was a poor college student. I didn't really have $20 to go buy a new computer keyboard, but more importantly, I was in the middle of typing something, and it was the middle of the night. There was no place for me to go to get a replacement keyboard. The importance of taking care of our equipment really hit home in a very personal way, and I have never made that mistake again. You do not want to destroy an important piece of technology because you insisted on breaking the rules. So generally, you'll find in most of our UMass Lowell facilities, we have space right outside the door or possibly right inside the door where you can leave your drinks, and that gives you a place periodically to take a break, stretch your legs, go drink a little bit of coffee or tea or water or whatever it is you're drinking, then come back in, get back to work. Once again, leave your drinks outside. Another important thing to know about the computers in 406 is they're set up with a software package called Deep Freeze. What this means is that every time that computer shuts down and restarts, the system goes back to a data state that was set up at the beginning of the semester. Any data you've left on that computer will be erased. So this applies to the system drive on the 406 computers. That includes anything on the desktop. You'll notice there is something called a thaw space. This is a space that does not get deleted during deep freeze. However, I want to caution you for relying on that for long-term storage of your data. That is where you should store your data while you're working on a computer in 406. But your data is your responsibility. When you're done working in 406, every time, every single day, you should be backing your data up to a personal drive that you will take with you. Remember, that thaw space is available to everybody, and while we don't generally think people will go around and delete your data arbitrarily, it is possible. It does happen, and it has happened. So, your data is your responsibility. You will not be excused from an assignment because your data was lost. If your data is lost, you failed the assignment. So make sure you are taking care of your data, that you are keeping it with you. Finally, we want to make sure that you're planning your lab use. 406 is in fairly heavy use this semester for teaching, so it will not be available to you at all times. It will only be available during certain times. You need to plan your schedule accordingly. Make sure that you're able to get into the lab with sufficient time to use it. You will not be able to stay late. You'll not be able to stay after hours. You will not be able to sit in this room and keep working when there is a class meeting in this room. You are expected to clear out of the room when a class is assembling in this room. So please be respectful of other students, be respectful of their time, and plan your lab use to make sure that you don't get yourself into a bad situation. Lastly, I want to talk about backups. Your data is your responsibility, and generally speaking, your data should be stored in at least 3 places. If you lose your data, that could be hours, days, weeks of work that disappears. There is nothing more frustrating, I assure you, nothing more frustrating than losing a lot of creative work that you've invested a lot of time and energy on, and poof, it's gone because you simply didn't take care of your data. So my personal workflow for all of my audio and video work includes a data drive, which is in my actual computer. That's the working drive where I'm working from when I'm editing audio, recording, doing whatever I'm doing. I have a backup of that, which is on an external drive, and my data drive is regularly backed up to that. I actually use a program called ChronoSync that automatically backs up my data once a day when my system is idle. There's a lot of other alternatives out there, including some proprietary ones that come from hard drive manufacturers, as well as things like SuperDuper. Or you can just, of course, do this manually, making sure that you're backing up your data regularly. The important thing is that you never want to let that get stale. If you've put in a week of work, that's a lot of work. You want to make sure that your backup is happening regularly enough that if you were to lose the data on your primary drive, it's not going to be a disaster for you. Finally, I have an off-site backup. This is what I like to call the backup of my backup. So that data, I keep it off-site. As terrible as it is to think about, buildings burn down, computers get stolen, things happen. So having your data stored in a separate location is the final key to making sure that no matter what, your data will be available to you. Particularly for students going into sound recording technology, it's important to understand your data is your lifeblood. That's how you make your living. And having good data storage practices, good data management practices, and most importantly, data backup practices are going to be essential to success in your career. For offsite backup, there's a lot of options. I use a network storage solution as well as an offsite data storage service. There's a lot of those for those of you that have small amounts of data. There are things like Dropbox, iCloud, Google Drive. There's a variety of alternatives. For those of us in the professional world, we usually find that those storage solutions don't work in the long term. We either exceed the data storage needs, or often our contracts will prevent us from working with data storage solutions that don't have key intellectual property protection requirements in place. So in any case, there's a lot of options out there, but make sure you are taking advantage of this stuff. So anytime you leave 406, you should have the data copied to a drive. You should ideally have your data copied to a second drive, and you might even take a minute very quickly to then upload that to Dropbox or Google Drive or some other kind of offsite network data storage solution.